Welcome to Software Craftsmanship. Why Istio Service Mesh? Software architectural style evolution. Let's say Amazon.com. If you see entire application as a single unit, then any bug comes or enhancement, you have to redeploy the entire application in monolithic style. The same Amazon.com has been divided into four major modules. Each module you can consider as a service: cart and checkout, search and browse, user profile, user experience. So that's nothing but SOA. It's a coarse grained. So if any bugs comes in or enhancement in particular service, cart and checkout, then you need to redeploy only that particular service. In fact, during the design and development, you get a lot of flexibility uh, than the monolithic style. And the next evolution is microservices. Further, if you divide this cart and checkout single large service into four more modules, then and most independent components, meaning you can design, develop, and deploy everything independently, as it has its own database as well. But the practical way of monolithic application migration into microservice is monolithic to SOA, SOA to microservice, unless it is a greenfield deployment. Let us have a closer look at monolithic and microservices, a user interface and business logic. The entire logic, meaning there are many components, but it is a single unit. Whereas in microservices, same logic can be divided into multiple microservices, and it has its own database, so that design, development, and deployment is easier, and it is cloud native application, what we call today, so that further you can support any of the uh, pillar of architectural pillars individually. But when the communication between the microservices is a challenge anyway. Let's say I have used the Spring Boot, Spring Stack, and REST API. REST API is nothing but architectural style, stateless, so that it is scalable. This is all microservices no pros. To support further all the architecture pillars like performance, scalability, security, circuit breaker, all that blah 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 is possible with Netflix, Eureka, or Twitter. There are many other open source APIs brought under umbrella of Spring Cloud. Now, using Spring Boot and Spring Cloud, meaning a Java stack, uh, you can develop beautiful microservices based application which is ready to deploy on any of the cloud service like AWS or GCP. Fine, so far so good. Then what about the polyglot microservices? Now each microservices is written in different language or technology stack, Java, .NET, Golang, and Python, all that stuff. Then how can we implement the other pillars what I mentioned here using Spring Cloud, load balancer or gateway or service discovery, histories, that this, right? So all that is not possible because it's not written in single language. There is no support, right? So we have to implement that stuff in infrastructure level. So let us, anyway, whether it is a polyglot or single language microservices, we have to use the virtualization in parallel to the software architectural evolution. The hardware evolution or the infrastructure evolution also you can see. If you deploy any microservices or a monolithic or any other style of application on hardware server, then it consumes hardly 30 to 40%, or depends on some percentage of the resources only it consumes from that hardware. So the evolution is virtualization, VMware, and then now Dockerization or the containerization, and Docker is very popular. So everything as an image, whether it is Spring Boot or a Python or Golang, any other microservices component, you can make it as a image of a Docker image, what we called. And to manage all these containerization, Docker images, we need some orchestrator called Kubernetes. So Kubernetes is mainly a immutable infrastructure. How it works, basically the smallest unit of Kubernetes is pod, then node. Each node you have pod, each pod is having Docker image. Docker image is nothing but at runtime Docker container. That's nothing but Spring Boot application or a Python application or a .NET application. So now these microservices need to communicate in a secure manner. That's where the service mesh come to picture. Is the solution. Service mesh is nothing but communicating secured way of communication between the microservices. So actually if some microservice is developed in particular stack and Python and other one is in Java, it cannot communicate directly. So where there is a concept called sidecar, that's nothing but a proxy. So how it communicates between these services is through proxies. We have to have a deep dive into service mesh things, but very high level. You have the real challenge is ingress traffic management. So Kubernetes is providing 4 options. Ingress API is having a lot of annotations, and so that is a limitation for that. Contour is along with the ingress you can overcome those limitations. There is a workaround with some annotations. Ambassador API gateway, it is also provided by the Kubernetes, which is much sophisticated than the other two. But the Istio ingress gateway is the best solution among the 4. So what is Istio? Istio is a platform for managing the complexity of microservices deployments using a service mesh abstraction. Thank you for watching this video. We'll continue what and how Istio in further videos. Before that, please go through istio.io where you have enough documentation, and at least you try to cover what is Istio. But after watching this video, if you go through this because you understood the problem domain well, now you understand why service mesh. At least now within the service mesh, why should we take Istio? And apart from that, better you cover what is the layer 7 load balancer. You have 2 types, layer 4 and layer 7. What type of load balancer we are using, with all that stuff we will cover. Thank you very much for watching this video.